Today, we are going to go a little more in depth into Blender materials. In a previous video, I talked about OBJ files, and here we are going to go a little more in depth into their uses. I'm starting today with a program called Autodesk Inventor, but this also works in SolidWorks, Creo, and many other CAD programs. Here I have this cube which I've set to have 3 different material textures on 3 of its sides, and then default on the other 3. On the top is copper, the left is red, and the right is a blue tinted glass. I'm going to be exporting this as an OBJ so that it keeps its material data when we bring it into Blender. In Blender, go to File, Import, Wavefront, OBJ. I'm going to navigate to the same file that I opened it in, and then we can see that as soon as I bring it in, it has that same 3 materials that I set it to have in Inventor. There are some differences between appearances in Inventor and Blender. For example, the copper comes in as gray instead of orange, but as soon as I go into rendered mode, it looks a little bit closer to before. But let's say that I think this copper doesn't really look how I expect it to. If I go into the scene collection and I find the name of my object, and then this little green icon triangle, and expand it, I can see the different material channels for the object. It doesn't carry over the names that Inventor had, which is a little bit frustrating, but you can rename them by double-clicking on the name at the top of the Node's Editor panel. Luckily, the Inventor name is based on the original RGB values for each material. Sometimes, if a material doesn't load in altogether, you can use those RGB values to closely approximate it in your Blender file. But let's say that I mess around with the settings and I still don't like it. I can go into Blender Kit and choose a new texture, and you'll see that even the name in the Scene Collection browser will change with that new material. If I want to edit a different material within the same object, maybe the blue glass, it's important that you do that in the Scene Collection browser. We can see that the one I just selected is the glass because the alpha value is not quite 1 or opaque. If I change the base color when we go into render mode, the appearance of the material will change. One important thing to note is that you're going to be tempted to use the drop-down in the middle of the nodes window to go back and edit your other materials, but that will just set your current surfaces to the material you selected. We really want to make sure that we're using the browser on the right. If we want to look at a more complicated object, I've got one as an example. It's the PFRC laser from Princeton. You can see that I've renamed all of the color channels so that I know what they're representing at a glance. It's a little bit tricky to remember which surface is which, so naming them can help a lot with that. I mainly bring this up as an example of something you can do with more complicated OBJ files. Again, this is an OBJ file, which is why I was able to carry its materials into Blender. If I had imported an STL, it would be completely gray, and I would have to select faces by hand using the UV editing tab, which is something that you should avoid doing, especially with complicated objects. One other thing that might be interesting is that this file has a background. Even though I don't like to have these backgrounds show up in my final renders, you can see that with the dog in the bottom right corner, it's a little bit pixelated, not great quality. But this file is what's called an HDRI. There are these 2 really great websites that you can look at for it. They're called HDRI Haven and Polyhaven, and most of the time their files are completely free for download and you don't need to cite them in publishing. HDRIs are super useful for giving your scenes a more natural and organic light. You can see I don't have any lights in this scene collection, so all of this nice, warm, even lighting is coming from the HDRI environment. To show you how to set up an HDRI, I'll open up a new file. Basically, you go to the globe icon, and on the yellow circle that says Color, you want to click on that and go down to Environment Texture, not Image Texture. You can see here I downloaded a completely new file from Polyhaven, and you can see that all of these environments will end in the .exr extension. All I have to do is select the downloaded file and our cube gets this nice, lovely blue lighting. One thing I will note is that if you download a Blender file from somebody else or a different computer, Most of the time, the environmental texture will not load in correctly. I'm downloading a previous file that I saved to Box a while back on my old laptop, and we can take a look at the environment when we load it in. You can see that when we go into rendered view, we get this crazy hot pink, not at all what we were expecting image, and that's because Blender is expecting an image that it can't find. To fix this, we just go into that world environment setting again. We can see right now it's looking for a file called Aerodynamics Workshop, and it's looking in my downloads folder, but it can't find it. So we go back into our environments folder and find that same file name on our device and select it so that Blender knows where to look. I expect this to cause a bit of a problem when sending files to other computers with better GPUs for bulk rendering, maybe something with the command line. The next thing I want to talk about is volumes. Volumes are interesting because they can make a file really come alive, but can sometimes demand a much higher rendering time. Let's start by turning this cube into a volume. Simply go to the Material tab and swap out the BDSF surface node for a principled volume. Then, simply disconnect the surface output and instead plug your volume node into the volume output of the shader. You can already see that Eevee kind of freaks out when it sees a volume, but still we can change settings such as density. Because of this, whenever you're rendering volumes, you really want to stick with cycles. Now, if I move the light inside the cube, you can see that the whole cube is lit up, radiating from that point. If we drop the density, you can see that that light permeates much further into the cube. Finally, you will probably want to turn emission strength down to 0 so that the volume doesn't light itself. We can see already that volumes are helpful in that they can soften and disperse bright light sources and help our renders look more natural. I'd like to show you an example of that with my Art of Science render. I'll show you the scene in solid mode so that you can have an idea of what's going on. You can see that when I rendered a version without the smoke, it took around 1 minute and 35 seconds. I then rendered the same image with the smoke, and it had a runtime of 1 minute and 40 seconds. Now, I'll note that in this file there are a lot of complicated things to render, such as the reflections on the hull, coils, and glass, and the hundreds and thousands of glowing particles, none of which changed between versions. But even so, the smoke took 5% longer to render. In a simulation with not as many particles or simpler materials, I've seen the presence of smoke double the render time. Let's compare the two results. We can see that, compared to the clear image, the smoke definitely obfuscates the particles nearest to the core. We could reduce that by lowering the material density. Also, in the smoky image, we can see that around the core, in the areas with white, there's this little subtle glow coming out. Also, in the clear image, there's not a super easy way to tell how close the core is. In some of my earlier renders, I even struggled with the fact that the core looked like it had been simply photoshopped in on top of the glass and the particles, which I really didn't like. The main advice I can give is to weigh all of these qualities and carefully decide if you think that a principled volume will add to or diminish what you are trying to show.